Modern oil extraction, 2025 technology and techniques. Today's extraction operations employ technologies so advanced they would seem like science fiction to the wildcatters who drilled the first petroleum wells in the 1850s. Modern drilling rigs tower over landscapes like mechanical giants, equipped with computer systems that can guide drill bits through underground formations with surgical precision, navigating around obstacles and targeting oil deposits located miles beneath the surface. These automated systems monitor thousands of variables simultaneously, adjusting drilling parameters in real time to optimize extraction efficiency while maintaining safety standards that previous generations of oil workers could never have imagined. Hydraulic fracturing, commonly known as fracking, represents one of the most revolutionary extraction techniques transforming the petroleum industry in 2025. This process involves injecting millions of gallons of water, sand, and carefully selected chemicals into underground rock formations at pressures exceeding 10,000 pounds per square inch. The extreme pressure creates networks of hairline fractures throughout previously impermeable rock layers, allowing trapped oil to flow toward extraction wells. The sand particles, called proppants, wedge into these artificial fractures and hold them open permanently, creating pathways for petroleum to migrate through rock formations that would otherwise remain sealed for geological time periods. Horizontal drilling techniques have fundamentally changed how oil companies access underground reserves by allowing them to reach deposits that would be impossible to extract using traditional vertical wells. Modern drill bits can change direction underground with remarkable precision, following the contours of oil-bearing formations for distances exceeding 2 miles horizontally while maintaining exact depth control. This directional drilling capability enables a single surface location to access petroleum reserves scattered across vast underground areas, dramatically reducing the environmental footprint of extraction operations while maximizing resource recovery from each drilling site. The engineering challenges involved in reaching oil deposits located 3 to 4 miles underground require solutions that push the boundaries of materials science and mechanical engineering. Drill strings consisting of thousands of interconnected steel pipes must withstand enormous stresses as they rotate through underground formations while supporting their own weight and transmitting power to cutting tools operating at extreme depths. The drill bits themselves incorporate industrial diamonds and tungsten carbide cutting surfaces designed to pulverize rock formations under pressures and temperatures that would destroy conventional materials within hours. Advanced sensors integrated throughout modern drilling operations provide predictive analytics on equipment performance, enabling maintenance teams to identify potential failures before they occur and schedule repairs during planned downtime rather than emergency shutdowns. These smart monitoring systems track vibration patterns, temperature fluctuations, pressure variations, and wear indicators across thousands of components, using pattern recognition algorithms to detect subtle changes that indicate developing problems. Unconventional oil sources have become increasingly important as traditional petroleum reserves decline, with shale formations and oil sands now contributing substantial portions of global production. Shale oil extraction require specialized techniques because the petroleum remains trapped within extremely low permeability rock formations that resist conventional extraction methods. Oil sands present different challenges, containing petroleum mixed with sand, clay, and water in deposits that require either strip mining operations or in-situ heating techniques to separate usable oil from the surrounding material. Environmental considerations are driving significant innovations in extraction methods throughout 2025, with companies developing techniques that minimize surface disruption, reduce water consumption, and eliminate waste streams that previously caused environmental damage. Advanced recycling systems now enable operators to reuse fracturing fluids multiple times, dramatically reducing fresh water requirements and eliminating the need to dispose of contaminated wastewater in underground injection wells. New drilling mud formulations use biodegradable additives that break down naturally if accidentally released into the environment. Enhanced oil recovery techniques use carbon dioxide injection, steam flooding, or chemical treatments to extract additional petroleum from formations that have been depleted using conventional methods. These secondary and tertiary recovery operations can increase total petroleum extraction from individual fields by 30 to 50%, effectively creating new oil reserves from previously abandoned wells. Many experts estimate conventional oil peaked around 2018, shifting focus to these unconventional sources and recovery methods. Safety measures in 2025 oil operations include enhanced blowout preventer systems that incorporate smart pressure monitoring, for real-time data transmission, and advanced sealing technology designed to prevent leaks even under extreme pressure conditions. These safety systems represent critical advances because modern extraction operations often encounter higher pressures and more challenging geological conditions than earlier drilling projects, requiring equipment that can respond instantly to dangerous situations. Artificial intelligence and robotics are transforming oil exploration by processing vast quantities of geological data to identify promising drilling locations and optimize extraction strategies. Machine learning algorithms analyze seismic surveys, well logs, and production data from thousands of existing wells to predict the characteristics of untested formations, reducing the risk and cost of exploratory drilling operations. Robotic systems now handle many dangerous tasks on drilling platforms, from making pipe connections to monitoring equipment in hazardous environments where human workers would face significant safety risks. Modern extraction techniques provide compelling evidence of oil's marine origins through detailed geological analysis conducted during drilling operations. Core samples retrieved from petroleum-bearing formations contain molecular fossils and chemical signatures that definitively identify marine algae and bacteria as the source organisms. Advanced geochemical testing can determine the specific types of ancient marine environments where oil precursors accumulated, providing scientific proof that contradicts any terrestrial animal origin theories. The sophisticated geological knowledge required for successful modern oil extraction demonstrates the complex marine depositional environments where petroleum actually formed, with drilling teams targeting specific rock layers that originated as ancient seafloor sediments rather than terrestrial formations where dinosaurs might have been buried. But understanding how we extract oil today only scratches the surface of the massive scale at which this ancient marine legacy continues to power our modern world. The numbers game, 2025 oil statistics that will shock you. The scale at which we consume this ancient marine legacy defies comprehension. Every single day in 2025, humanity burns through over 4.3 billion gallons of oil, which translates to roughly 102 million barrels flowing out of the ground and into refineries, gas stations, and industrial facilities across the planet. To put this staggering consumption rate into perspective, imagine draining an oil tanker the size of a football stadium every few hours, continuously without pause, 365 days a year. This relentless demand means that in the time it takes you to watch this video, the world will have burned through approximately 1.8 million gallons of petroleum products for transportation, heating, manufacturing, and countless other applications that keep modern civilization functioning. The economic scale of this consumption creates market forces that dwarf most other global industries, with daily oil trading volumes exceeding $1.5 trillion and price fluctuations capable of triggering economic recessions or fueling inflationary spirals that affect billions of people worldwide. The International Energy Agency projects that global demand will continue climbing toward 110 million barrels per day by 2045, driven primarily by transportation needs in developing countries where car ownership rates are expanding rapidly as middle classes grow and urbanization accelerates. The United States maintains its position as the world's largest oil consumer in 2025, burning through nearly 1 billion metric tons annually, which exceeds the combined consumption of China and India despite having a much smaller population than either country. American oil consumption patterns reveal the deep integration of petroleum into every aspect of daily life, from the obvious uses like gasoline and diesel fuel to the hidden applications in plastics, pharmaceuticals, cosmetics, fertilizers, and thousands of other products that most people never associate with crude oil. China represents the second largest consumer market, With demand driven by rapid industrial expansion and a growing transportation sector that adds millions of new vehicles to its roads each year, India rounds out the top 3 consumers, with its massive population and developing economy creating enormous appetite for petroleum products across transportation, manufacturing, and household energy needs. Global oil production in 2025 concentrates heavily in a handful of countries that control the majority of easily accessible reserves, creating geopolitical dynamics that influence international relations, trade policies, and military strategies worldwide. The United States has emerged as a major producer through hydraulic fracturing technologies that extract oil from shale formations, fundamentally altering global energy markets and reducing American dependence on imports from traditionally dominant suppliers in the Middle East. Saudi Arabia continues to play a pivotal role in global oil markets through its ability to rapidly increase or decrease production levels, giving the kingdom enormous influence over worldwide petroleum prices and economic conditions in oil-dependent nations. The kingdom's proven reserves exceed 260 billion barrels, representing roughly 17% of all known global oil deposits, and providing the foundation for production capabilities that could last for decades at current extraction rates. Russia maintains significant production capacity despite international sanctions and geopolitical tensions, with oil exports providing crucial revenue for government operations and military expenditures. The country's vast Siberian oil fields contain reserves estimated at over 80 billion barrels, though extraction costs in these remote locations remain substantially higher than operations in more accessible regions. Current proven global oil reserves total approximately 1.7 trillion barrels, according to industry estimates, though this figure includes deposits that require advanced extraction technologies and higher oil prices to become economically viable. At current consumption rates of 102 million barrels per day, these reserves would theoretically last about 45 years. But this calculation oversimplifies the complex relationship between demand growth, technological improvements, and the discovery of new deposits. Many experts estimate conventional oil production peaked around 2018, with future increases coming primarily from unconventional sources like shale formations and oil sands that require more energy and resources to extract. Recent discoveries of substantial oil deposits in unexpected locations continue to reshape global reserve estimates and production forecasts. Guyana has emerged as a major new producer following discoveries of over 11 billion barrels in offshore fields that began production in 2019 and are expected to transform the small South American nation into one of the world's largest per capita oil exporters. The concentration of oil reserves in politically unstable regions means that supply disruptions from conflicts, sanctions, or infrastructure attacks can trigger global price spikes that affect transportation costs, food prices, and manufacturing expenses worldwide. This vulnerability has prompted many nations to develop strategic petroleum reserves and diversify their energy supply sources. Climate change commitments made by governments worldwide are increasingly coming into conflict with continued oil development projects, creating policy tensions between short-term economic interests and long-term environmental goals. Many countries have pledged to achieve net zero carbon emissions by 2050, which would require dramatic reductions in oil consumption that seem difficult to achieve given current demand trends. The finite nature of petroleum reserves, combined with mounting environmental costs, suggests that the current era of abundant oil will eventually end regardless of how much remains underground. Knowing oil comes from ancient algae underscores the need to protect modern oceans and invest in renewables tailored to their marine roots.